Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about Arduino. So let's dive right into it. Well, first we have to understand what the heck we are talking about. We are talking about an open source hardware because even though you buy a equipment or hardware, you do not know the secrets of it, basically how the heck it works. And if you try to reverse engineer it, you can put yourself in serious harm's way legally and some otherwise also. So it's something that people generally can't do because again, you do not have like schematics of how an actual microcontroller is built. Here it's completely different. Whatever Arduino sells, you can actually understand how the heck it works, like to the tiniest detail, because it's an open source hardware. Then hardware is meaningless without a software, so they also take care of the software end. Now what they sell you, like what product do you actually buy? You buy a single board microcontroller. So you may think this looks like a Raspberry Pi. Technically true, because again that's also a single board solution, this is also a single board solution, but that runs on microprocessor, this runs on microcontroller. So it can, both of them can do more or less the same thing. Only difference is this is much less powerful, basically by the factor of 1,000 minimum. So microprocessor, like if you add multiple processors, you make a core, you make that core into a bigger core by adding multiple of them, and then you create the architecture, then you make the ARM processor. Here it's very simple, it's like a very smallest unit. Now you might be like, well, then what's the point of it? Not every time it's like if you need to make a move a mountain, you need tunnel boring machine. But what if you just need to dig a ditch? You're gonna use something appropriate for that task. Same thing, this has a lot of appropriate use for it. Now selling point of this microcontroller is something that you can buy from many companies. There are many foundries, many silicon manufacturers that mass produce a lot of these things. However, the fact is you have to have some serious equipment in order to basically program it. On this puppy, you program it as many times as you want. Basically, you can experiment with hundreds of variation if you need to. Or basically, the code that is running on it defines how it operates. Let's say you want to set this up as a auto stepping transformers main logic board. It has to have certain way of acting to things. Basically, you may be like, hey, if the voltage fluctuation is not stabilizing, do not change. You will like okay, just stay wait for a few seconds or something like that. Or you did that, you built that, you tested, it's like, yeah, it's good, but then you're like, no, this has this side effect. Then I'll be like, okay, trigger a cutoff if signal is too noisy. You have to reprogram it. This will allow you to do that. That's the whole point of it. Now, why the heck you want to do this microcontroller business? Well, reality is everything that you see that has electronical component inside it, there is a very good chance it's a microcontroller, which I'm talking about, from washing machine to microwave to refrigerator to air conditioner to your wristwatch to every Tom, Dick and Harry thing I can think of generally has a microcontroller, unless you're talking about torch. Nowadays, even those have that because they have like SOS and all that jazz. So microcontroller is something that is tangibly very important to our real world, flat out, and understanding them is kind of necessary for basically students and engineers who's gonna be building it for the future. So it's necessary for them. So problem was like the people in Italy who started this, the problem was that there was no easy way of doing it. It was not like, okay, buy it and practice with it and learn and become more polished and go along. Because breadboard, if you're familiar with any sort of electronics, breadboards are a thing. And this was like, this really allowed engineering, electronical engineering to be taught very easily, because like, hey, these are the components, try an experiment without soldering and destroying things, expensive things. And it is necessary because again, you cannot just directly start running. That's the sole reason we learn from how to write with pencil, then we start to use pen. So same thing was that engineers and all that, many times they were stuck in a scenario. It's like, yeah, you will learn how to use this microcontroller. Once you actually get the job to reprogram that microcontroller, like what the hell? So chicken and egg situation happens. So they tried to break it in 2003. Professional tools were ludicrously expensive, ludicrously. Like the cheapest that you can buy off, as in like in 2003, was wow. It was like wow. Just look up the price of microcontroller processor. And EVFlow did many microcontrollers reprocessing station, which was used by NASA and all that. Again, cost was like wow, like Lamborghinis, Ferraris, those are like chump change, bro, chump change. So it brought down something that extreme to something tangible, because the everything was made open source. So that's why it was not a luxury tool, it's a necessary tool for learning. Now Arduino is not the only one, there are other options also, but Arduino is the biggest and the most popular one. Now, how does it actually work? Well, microcontroller is the core of it. That's it. And Arduino does not make microcontroller. There are other companies that manufacture it, like let's say Atmel. So Atmel will make the microcontroller. Now, you can buy breakout boards for each microcontroller. So which many companies do if they are like, hey, we're gonna be releasing a, let's say, a keyboard. Let's say Logitech is like, bro, we're gonna release a keyboard. So the engineer will be like, hey, I think we'll need some sample size where we can figure out which microcontroller is best suited. They will order like, one from, let's say, some other vendor, another from another vendor, another from another manufacturer, and they'll get something like this. This is just a breakout board. That's it. There is no logic, nothing to it. Now, like, isn't this like a Arduino? Short answer, no, because if you have this, you can't use this. You need power and clock systems, bare minimum, just to turn this damn thing on before you reach into a point where you're like, okay, I'm gonna couple DC voltage to it, take 3.5 volt out of it or 3.2 volts. All those things require an additional circuits that you see in the Arduino. That's what they are. So you do not get this, because again, these are suited for engineers and all that who know what they are doing, and they are like, okay, we're gonna build this and experiment things out, and then they are like, yeah, okay, order like 10,000 of these, 20,000 of these, depending on their product requirement. So that's completely different. That's for professional. But what you gonna do as a learner, as a student, as a tinkerer, as a hacker, what you gonna do? You're gonna buy something that already has those power, clock cycles, decoupling capacitors. You do not have to think about that. The company will take care of that. But the breakout board still would be there, so that means you can still have access to all the pins, which is the important part. This is how you interact. Basically, if you design a motor or a robot needs to control the motor. Motors needs like a physical interaction with your software. They can't just magically do something like that. So for that reason, pins are important. So breakout board allows you to communicate to that part, and then you apply the software is Arduino IDE, integrated development environment. And whatever code that you upload, for Arduino we call it sketches. Don't think too much about it. It's just like it's just a file that you upload into the main system. That's the working of it. You take the microcontroller, you apply power, clock cycle, or grounding plane, everything that is necessary, and then you kit it out with a breakout board. Then you run the software, and tada, you have fully working Arduino. And people do build that. People do actually build a full Arduino. Once they have done the development, so they know the software, it works and all that, then they will do, let's say, for mass production, because Arduino can be utilized for mass production. You will do something like that only, because again, it's not tangible to have like such a junky thing for such a microcontroller. So many times people have asked me what to buy or what to do this. I generally try to stay away from that, because I do not know your need case. However, in this scenario, I can be damn sure, absolutely positively guaranteed, if you are a beginner, if you're like, okay, Arduino is something that I'm gonna invest my time into, which Arduino should be my first Arduino? I can guarantee that should be Arduino Micro, not Pro Micro, Micro. The reason for that, both Micro and Pro Micro have Atmega 32U4. Now, microprocessors are basically completely different beast. They are much more bigger and powerful. Consequently, their power consumptions are also huge, and they are not very what you call real-time efficient. So when you talk about microcontrollers are very, very efficient, as in like watts are not big enough unit to measure how much power these puppies are consuming. You have to go to microampere in order to measure it, how much they consume power. So for this reason, microcontrollers use very old architecture, aka serial communication interface. If you are familiar with very old computer, vintage computer, as in like 1990s, before USB, there was a serial interface. Microcontroller relies on that. So when you buy let's say Arduino Uno, which is running on old architecture, it has a microprocessor, basically microchip. Everything is working fine and dandy, but it needs an interpolation chip. Basically, a chip will be like, okay, I'm gonna read the serial data and I'm gonna transmit it into USB, because again, you have to transmit it using USB. On this puppy, basically Atmega 32U4, there is no need for interpolation. This is more advanced, more modern built microchip, and it has USB inbuilt into it. What does that allow you to do? Well, first, it removes one layer, and more complexity you remove, the better your products get. And another aspect, many times people want to build something that interacts with computer. You have to, heck, let's say you want to build a game controller, you have to have a way to directly interact with computer. Now, can it be done with Uno and all that? By tampering with bootloaders and tampering with things which is not suited for a beginner. Can you do that? Still no. People will still flat out say, yeah, I tried this with like, and I bricked 4 Unos and then fifth one worked. So people generally want a stable solution. And again, if you want to build a product, you don't want to like, hack around things. You want like, hey, give me something that inherently does that. So this puppy does that. So you can buy this, build a equipment. Let's say you want to build a simulator, basically where you have steering wheels, lots of buttons and jazz and all that. This puppy can directly communicate to your computer over USB without any extra hassle. You just have to load up the correct library, gamepad library generally. And this is the whole reason, and the reason why I'm saying not by Pro Micro, while they had the exact same microchip, is the pin count is less. Simple fact. And most of them, both of them, generally cost almost the same. The cost wise they have almost the same. And basically Pro Micro is just you chipped off the, like, last 4 pins. It's just that you chipped off the pin. That is why I generally recommend Arduino Micro, and it has more pins, and you have 20 accessible pins, flat out 20 digital input and output pins you have accessible. So that means if you want to build a keyboard, this puppy is very close to actually making it, flat out making it. Especially if you are making a 60% and all that, you can easily do that. Unfortunately, if it had 2 or 4 more pins, it would have been actually allowed to do full-fledged keyboard, because normal keyboard, standard American keyboard, which is this, something like this, this has 104 key. So if you have 10 by 10 matrix, in order to do that, you will get around 100 keys. So it does have 4 extra key, pins, but those are hard to access. Basically, they are in a reprogramming header, and SS circuit is there. You can get like all 24 pin, but I have not tested it whether it's stable in the software or not. So that's why this microcontroller is the most amazing one, because of the USB artifact and how its package is directly goes into a breadboard. Or basically, if you want to experiment with your PCB building, you have to experiment starting with something like this, which we call perf board. Now you can understand the whole pattern is the same. The whole pattern is exactly similar to a what we call breadboard pattern. So the pins that you see here perfectly aligns. You don't have to think about it. Like, you can just plonk it here without any issue. That is why you can't plonk a Uno here, but you can plonk a micro here. That's why this is perfectly suited for something that you start building, and as you get better and better in programming, electronics and all that, you can literally push it off to a final product. So that's the amazing aspect of it. Then what project I have been doing with this, because again, all I'm saying is just blah 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 blah. Have I done anything actual with it? Short answer, yes. The reason is I have seen basically a lot of videos of macro decks and control box and all that, Elgato Stream Deck, so to say, and I did try to recreate it using some free softwares, and I did successfully manage to pull that off using my old Android phone. That's amazing and all that, but then I saw this puppy, Loop Deck. Now, if you are familiar with Lightroom, which is the perfect tool for raw file editing, it's awesome, but it has a lot of sliders on top of sliders on top of sliders, and it's not an issue if you have to only edit like 5 or 6 photographs, but if you have to shift through, let's say, hundreds of it, which sometimes if I go into family occasions, I end up with, as a like de facto photographers, that time it becomes very frustrating, like doing something like that. So something like this, which we call generally decks, are very time saving, because you can see all the knobs that you have, they only control one thing and one thing only. Basically, there is one knob only, it will only affect clarity, another contrast, another exposure, another blacks, another white, another shadows, another highlights, another variance, another saturation, temperature, tint, and all such stuff. On top of that, it also has another 8 encoder wheels, which are just hard coded to the colors of each file. Basically, red, orange, yellow, green, sky blue, dark blue, violet, and all that. So all those things are in first layer control. You don't have to go somewhere and tamper. So basically, you can do file management, file editing, so to say, the raw file editing on full screen. You don't need interface. All of these will do the same thing. And if you are familiar with any industrial workload, basically even sound designer, they have like giant decks. Why they have that? Because again, if you have to do that daily, saving time is important, and these things allow that. Same goes for video editors and all that. So I'm like, okay, it's fun and awesome, and what was the price? And I got a heart attack after that. So I'm like, nope. So I thought, hey, let's try to build it. Now be mindful, I'm not an engineer, not a basically electrician, not a programmer. I don't know anything about anything. So I'm like, let's build it, because I'm crazy like that. So I built this. Now this is a proof of concept. I have successfully built it and tested it. It does work. So what is happening is there is a lot of library into this, and I'm utilizing this as a gamepad, not as a keyboard system, as a gamepad. The reason for that is it's gonna send gamepad command, and if I do wiring mess up or this gets stuck, it's gonna only tamper with a gamepad. So it will not freeze my software, because if you send direct keyboard shortcuts and for some reason your software gets stuck, or you have a faulty wiring, you will mess up the keyboard. So you have to remove this, then problem will become how the heck you're gonna reprogram it. So I made this as a gamepad. This talks to auto hotkey. Now benefit of that is auto hotkey has intelligence. So based on that, let's say this knob, yes, it is a fan knob, and I'm like, If VLC is active, this knob will do control up, control down, basically volume up, volume down. Now here's it. What happens if I go to Chrome? Now in Chrome, I don't want that function, basically volume up and down, I don't want that. But in Chrome, I do want the ability to zoom in and zoom out. Same knob I can do like this, and it will do zoom up and zoom out because of auto hotkey. Basically, auto hotkey allows me to have a condition applied, basically check which application is running. And if you have been like 3D artist like me, where you have 3ds Max, Maya, Blender, Photoshop, God knows how, like Marmoset, Unreal, and ZBrush, and Quixel, and Substance Designer, Substance Painter, or Fusion 360, and all that. All these software have export. None of them have same keyboard sorted for that. So idea with something like this is like you just have one button, you press it, and the software, basically auto hotkey, figures it out like, okay, this dude is activating, working right now in 3ds Max, send the 3ds Max command for export. This dude is working in ZBrush, send the command for ZBrush. So that's why I wanted the auto hotkey. Does it work? Yes, I have tested. This is a complete proof of concept. Again, not the final product, but the proof of concept is there. So the idea is I'm gonna build, once I actually have the money and all that, a final keyboard, something like this, like battleship kind of system. Because I'm not sure whether you guys know all that, there is a F13 to F24 by default built into Windows. It's already there, so you don't have to code some extra thing. It's like all those keyboards are there, so you can do that. So this keyboard was like built with Teensy. It's like a bigger brother of Arduino, and the benefit would be that, imagine side keys, I will just simply name export, and if I press that, the computer will figure out, hey, he wants to do export, and I don't give a damn. Like I have to just press one thing, export. It's gonna solve the everything for me. That's just one thing. There are hundreds of things like this where, like, even undo. Let's say for some reason undo is a try button combination. You don't want to do that. It will hurt your hands if you have to do that daily, which I had to do. So that's the whole point. That's why I'm building this, where I'm gonna have a basically microtech. Again, this is a starting point where I'm only working with 32 keys, because USB gamepad has that as a default. You can push more than that, but that's default. So I'm starting here, and this is my final end game. This is what I want to do once I have the money, because this will cost a lot of money to have like upwards of 130 keys. And I'm not even sure that whether I can get that all these keys in current microcontroller. I may need to upgrade to 10C one way or the another. So this was my presentation on Arduino. I hope my presentation helped to clarify what the heck it is, why the heck people are so excited about which Arduino is a good starting point, and can you do something like that, because I do not know anything, and yet I have successfully managed to build it. So I'm reasonably sure if you have any modicum of programming experience, you can be like, yeah bro, wait 5 minutes, I'm gonna outsmart that. So enjoy, build it, like just try it, just go YOLO. I have provided some videos down there which you can see for inspiration and all that. So if you liked it, please click the like button, share it amongst your friends, that will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment, because I like to reply to all of them. And subscribe, press the bell icon if you're free, and as always, thanks for watching.